Hello everyone and welcome to another episode of Interstigation. In today's episode of Interstigation, I will go over the extended product rule. And in the extended product rule, we're actually going to be finally able to differentiate a product of more than two functions. And before that, let's get started on our daily problem. And the daily problem would be find the derivative of this complicated thing. Pause the video if you want to try this problem and proceed the video when you're done. And let's get started by color coding what composite functions that we actually have, because this obviously is a multi-layer composite functions. We have to use chain rule over and over again to actually differentiate this thing. And what we actually over here we have is, first of all, it's the tangent of the inverse of tangent function over here, and inside that we have the sine. So that's the sine. However, notice that there is a squared over here, and we actually need a specific chain rule for that. So that's squared. We have the sine of this thing, and the last function inside will just be x squared. That's a pretty complicated function. And let's get started by listing out everything that we want. So we want the derivative with respect of x of tangent, the inverse tangent. We want the derivative with respect of x of sine. And also we want the derivative with respect of x squared. Let's start with the easiest one, which is the x squared one. That would just simply be 2x. And the sine of x is pretty easy as well. That's cosine of x. And the inverse tangent, as we've went over from last video, that would be equal to 1 over x squared plus 1. And this, we can get started by using our first chain rule on inverse tangent. That will be equal to 1 over, this what we have is plugging this inside function as x, will be sine squared of x squared. That squared plus 1. We need to multiply it by the derivative with respect of x of this inside function. Like that. And what we have over here, we need to use the power rule and the chain rule on this squared over here. And that would be, so this, we can just write that as the fourth power of x squared plus 1. So that will be plus 1. And multiply it by the derivative of this thing. We need to get rid of the square first. And to get rid of the square, we can use the chain rule again. That would give 2 times this sine of x squared. So this is the x that we are plugging in. So that's sine of x squared. And multiply that by the derivative with respect of x of sine of x squared. And notice everything like over here and everything in blue, this and this will be the same. Also over here, this and this will also be the same. Let's recompile it a little bit. So let's rewrite this as 2 times sine of x squared times this derivative. And this derivative, we can just use cosine. And let's differentiate that. That's just cosine of x squared. Obviously, we have to use the chain rule again. That's times the derivative with respect of x squared. Like that. And that denominator is equal to this. And what we have over here is just simply this. Now this x squared, we can rewrite that as 2x. And let's combine that one of the two over here. So we get 4x times sine of x squared times cosine of x squared over sine to the fourth of x squared plus 1. And over here, our problem is basically done. You really cannot see a very easy way to simplify this a little bit. Although you can use the sum of angles, the double angle formula over here. So that's the double angle formula for that. But you really don't have a purpose for it, and you can just leave it like that. And let's get into what we have for today. That is the product rule expansion. And the product rule expansion, we have 3 or more functions. After getting 3, we can just plug the equation back in over and over again to get more functions. So we can start with 3 functions, and if we see a pattern, then that's it. We can use that pattern most likely. And we want to differentiate these 3 functions, the derivative of the product of 3 functions. And obviously we're going to use the product rule, and the first product rule we're actually going to use, we can see this h of x and g of x as one function and differentiate using the product rule on top of that. So that is just going to be equal to the derivative of f of x times g of x times h of x. So this is actually, you can consider this as one pack, h of x, and we need to add that. So add this f of x times the derivative with respect of x of this g of x times h of x, like that. And the first part is already done. In our expression, we can just write that as f of x times g of x times h of x. In the second part, we need to use the product rule again. And that will be equal to f of x times what we have in here is actually equal to, so that's g prime of x, h of x, plus g of x, h prime of x. That is what we have over here, and we can just multiply it out to get, let's write it like this with color so that you can see the expression a little bit more. So like that, plus the f of x, like that, times this g prime of x times h of x, and plus this f of x, so f of x, g of x, but multiply it by h prime of x. And that is the extended power rule. And that's actually pretty straightforward, and it's just 3 additions with each term with one of them differentiated, and you can expand that onto 4 functions, 5 functions, or even more. You're good to go. So this is more like an example, and it is very helpful when you're trying to differentiate a lot of functions, especially a product of a lot of functions. And that's it for today's episode of Interstigation, and I will see you in the next one. Goodbye.